and he is the Science and Operations Officer at the National Weather Service in Northern Indiana, serving since 2001. He graduated with a BS and MS in Meteorology from Northern Illinois University, and he taught at the University of Memphis before going into forecasting. So everyone, please welcome Jeff.
Nice to be back here. Actually, it's been 15 years since I've been at the Symposium. I gave a presentation just after the F4 Van Wert tornado back in 2003. So we're not going to look at quite as intense a tornado as the Van Wert one, but it was a very interesting one in terms of it being a very long track tornado. And so try not to be too redundant with what Corey presented, but we will take a look at some of the aspects that led to this, the cyclic nature of this low-top supercell that ended up producing that tornado. So as Corey showed in the event overview, one of the things I wanted to point out with this is that this was a multi-faceted event for RCWA as well, in terms of looking at both flash flooding considerations and severe thunderstorm warnings early on in the event. And then it wasn't until later on that we had the tornado spin up in our far southeast portion of our county warning area. And so the actual thunderstorms began shortly before noon, and so we were already issuing warnings early on in the day. And so it's easy to lose your situational awareness if you get kind of lost the track with, get busy with the severe thunderstorm warnings and flash flooding in the northern CWA, and you don't want to lose sight of the sort of the clean area that ended up in our southeast CWA that led to the destabilization shortly after noon and allowed that tornado to develop. So it ended up being a 39-mile long track tornado starting just in Indianapolis's county warning area in Delaware County near Eaton, Indiana. And as I was looking at this map, I was looking at the endpoint trying to find a town in western Ohio, and also we can refer to that as a rural western Ohio area. But I did find Cassie's Country Covered kept coming up on Google Maps. So if you're ever in rural western Ohio, stop by Cassie's. But anyway, this was 39 miles long. Had the entire track been in the state of Indiana and not gone into western Ohio, it would have been the record for the longest tornado track in Indiana for the month of November. But it did go into western Ohio, and so the Kokomo tornado back in 2013 still stands as the November record. Corey went over a lot of that. The one thing I wanted to point out with the SPC and our hazardous weather outlook, that this was a very well anticipated event. Corey mentioned that Nick Greenwald presented here last year, and he did that August surprise tornado outbreak where the expectations for tornadic weather were very low. Well, this one was pretty well anticipated event, and so we were kind of geared up and ready to go in terms of our severe weather operations. So in looking at the warning operations, we usually take a 2 out of 3 rule approach. And so we're looking for 2 of these 3 factors to come into play in issuing tornado warnings. What wasn't present this day was there weren't readily apparent radar signatures. In our far southeast CWA, Wilmington, Indianapolis, and the northern Indiana radar are all hitting the lowest beam height over 5,000 feet. And so, as Corey mentioned, the low LCL heights, less than 1,000 feet, you're going to be, and the non-descending nature of the tornado development would suggest that you're not going to be able to see those good radar signatures early on in the development. Reports of confirmed tornado and or extensive damage was not present as well. We only had 1 wind damage report prior to this tornado. And so what we focused on was the favorable mesoscale environment and the storm scale interactions. And so this is sort of one of the things we're really preaching in our office, is to attain that good situational awareness, and Corey mentioned this too, you need to have a mesoanalyst constantly assessing those near-term changes in your environment. And so when we approach our severe weather, having been the Sioux there for now 17 years, I always ask my forecasters, well, what's your threshold of pain today? So you want to go in with an idea of what is it going to take for you to see on radar to issue a tornado warning. There are days where you better see a really good signature before you think about issuing a warning because the environment just isn't favorable. And then there's other days where you have a very favorable environment and you're not waiting to see much on radar before you're pulling the trigger on that tornado warning. And so as the event sort of spun up into the early afternoon hours, Todd Holston, our lead forecaster that was on duty with this event and helped me put this presentation together, was the mesoanalyst. And he was poring over that data that afternoon and was feeding it to our radar operator, and he was convinced we were going to have a tornado somewhere in our southern CWA. But just a word about mesoanalysis. Looking at composite indices is not mesoanalysis. So seeing that SIG tour of 2 over there and say, well, we're going to have a tornado today, my job's done, is not what mesoanalysis is. So I'm sure your professors relay this to you. It may be good to get an idea that where you might want to interrogate. And it's also, if you have a low expectation of severe weather or tornadic weather, it might wake you up to, hey, I better start paying attention. But make sure you know what goes into these composite indices and know how much each parameter contributes to that composite index and what the value or changes in those values will tell you when you just look at a SIG tour of 1 or 2. So another thing we do at our office is hand analysis, and we're really into printing off maps and actually getting into the data and getting a good feel for how that environment's changing. So this is an 18Z hand analysis that we did that day, and you can see the X there is the pressure fall of 2.7 millibar max prior to that front arriving and the tornado developing. And so the pressure fall analysis gives you a good indication of some of the mass flux changes that are going on and the destabilization out ahead of that front. Finding these little waves, whoops, no, went too far. Finding those little waves along that frontal boundary are also beneficial because one of the things we look at in terms of finding an environment favorable for tornado development is that backing of the wind near the surface. And so those little waves of low pressure forming along that front will help steer those winds in a backing direction for you. So the star indicates the area where the EF2 tornado first touched down, and you can see the mesoscale analysis that Corey already talked about indicated sort of a very highly sheared environment and a modest cape environment. And those tend to be our most favorable conditions, at least since our office opened in the late 90s, of what we've seen for good tornado days. We find that if we have too much cape, you end up getting, actually your thunderstorms develop too tall, and you get ice developing in them, and you get more of a favored cold RFD instead of that warm, buoyant rear flank downdraft that you're looking for in tornado genesis. So just zooming in on there, you can see that we had a little over 1,000 joules of cape in our far southeastern CWA, and so that's what we're looking for. A lot of shear present and just enough cape to get things going. And so bulk shear, very favorable. The theta E near the surface and the theta E advection showing that good moisture surge out ahead of the front. And as Corey mentioned as well, the precipitable water below 400 millibars overlaid with the 0 to 1 kilometer storm relative helicity. So you've got all of those parameters coming together right at the right time, right near your max heating for that time of the year. Now you translate that parameter space into a nearby sounding just prior to the tornado development, and you can really get an idea of what the environment was that favored the development in our area that day. So you get just a little bit of a backing there. Usually you want a little more of a southerly to southeasterly component, but it was enough that day. LCL's literally scraping the ground just actually below 1,000 feet, and just enough cape to get things going. And so this was actually the radar signature that we based our first tornado warning on. And you can see that if you look at and based it just on the velocity signature, 9 times out of 10 you're not going to be issuing a warning with that kind of a signature. But this is where the team effort in our severe weather operations came into play, with Todd saying there's going to be a tornado, we need to issue a tornado warning on this storm. And so with that in mind, we were able to get the 21-minute lead time, but had you waited for the better signature, you would have only ended up with about a 4-minute lead time. So just 20 minutes later, now you have that nice good velocity couplet that you'd be looking for, right as it's about to enter our county warning area in Blackford County there. So that cooperation between the mesoscale analysis and the radar operator was key this day in getting a little bit more lead time on this one. Unlike some of Corey's analysis and their Ohio tornadoes, our CC plumes were rather sporadic and intermittent. That area in rural Indiana and Ohio, mainly farmland, and so if it wasn't actually hitting a structure, it was passing over fields that had already been harvested, so there wasn't much value to be gained from the CC data until it actually came into encounters actual structure. So here's some of the video from it, and what's really interesting about this is if you look at it, you can really see the cyclic nature, the multi-vortex nature of this tornado, and it did give us a little bit of trouble with our polygons as it kept cycling through there. And as we get a little bit further on, you'll see some pretty significant damage.
Yep. Oh shit.
Okay, R rating.
Yeah, no, we're okay. It's okay. Go ahead and go down the road some. Get away from this. Get going.
It is nice to see smart storm chasers that maintain that safe distance every now and then.
Oh my God, major damage. Major damage, large tornado. Call 911, David, and keep driving. You gotta keep going. I want you to go down. Major damage, large tornado. Yeah, just nice and easy. Stop.
So that was pretty good footage that we're getting. And another interesting aspect is, the National Weather Service, breaks off into multiple efforts with decision support services. One of the time-honored traditions of DSS is storm surveys, where we get that interaction with our public and emergency managers as we survey this damage. And on this particular day, Todd went out and did the damage survey and had some incredible survivor accounts of a couple of different couples who were lucky to be alive after this tornado event. You can see the extensive damage carried well downstream of where that house and building were completely destroyed. And this is an account of somebody who actually left their house and went into a ditch, and they lived because they did that.
Okay, these guys jumped in the culvert. They see him coming and jumped down the culvert.
Hard to hear him, but what he's saying is that he saw the tornado coming and said, we got to get out of this house, because they had no basement and no really good safe interior room to take shelter in, and their house was completely destroyed. Had they stayed in there, they probably would not have survived. So that's incredible presence of mind to think to go into a ditch instead of just taking shelter inside your home. Then Todd also had a chance to speak with another couple who ended up taking shelter in their hog barn, which was completely destroyed. The red arrow is pointing to where they were sheltered in there. So they were tending to their hogs when they saw the tornado coming, and they just dove for the southwest corner of that barn, and as they were huddled there together, the barn was completely disintegrating around them, and they did not think they were going to survive. But luckily, they were able to come out of there with just a few scrapes and bruises. So a couple of really amazing survivor accounts as we did the damage survey for this particular event. And this was a real head scratcher for Todd, as this was one of those half circle barns, and it was made by a retired engineer. So it was riveted to this concrete base to it. And so when Todd first saw that, he's like, holy crap, what would cause that to just be pancaked like that? And so we got in touch with Tim Marshall, one of the damage degree indicator experts that we have, and he indicated that since the structure was completely sealed up, he theorized that it was the pressure perturbation as the tornado went right overhead that actually caused it to just be completely smashed like that. And the arrow indicated that he had a collection of classic Harley-Davidson motorcycles in there. And so that might be the most tragic casualty in this particular event. And we had, in combination with ground surveys, we also had a drone operator following us that day, which was very beneficial because the combination of looking at these ground-based damage in conjunction with the drone can show you these white lines indicating the multi-vortex nature and the way those multi-vortices are converging together down here in the corner of that diagram. And you always see something interesting when you're out on the storm survey. So if you happen to get a career in the National Weather Service, always volunteer to go on the storm survey. You see this little, not little, backhoe here. If you look at it closely, that tornado caused it to do quite the little curlicue there in the parking lot. So, always something interesting, but that's all I had for this presentation, and Josh also asked me to present something on the record flood that we just had in northern Indiana, so if we have time, I'd be happy to show that one as well. Okay. So I don't know if you want to do questions first, or just let me go through the other one.
Yeah, why don't we see if anybody has questions on the tornado presentation, and we'll do over on the flood. So any questions on tornadoes? No? All right, we can just start with the flood.
So between November and February, it's been a busy time of year here at the Northern Indiana office, where we had unprecedented, at first it was a 50-year flood, then the rivers kept rising, then it became a 100-year flood, then it became a 500-year flood. So it was quite extensive flooding, where over 6 inches of rain fell in a 48-hour time period across the western and northern portions of our county warning area, resulting in some record crests for both the St. Joe River at South Bend, which peaked at 12.7 feet, which set a new record. The old record was just over 10 feet. And the Elkhart River at Goshen also set a record at nearly 12.5 feet. So just a real quick summary on this. What caused the heavy rain? And if you look at the actual meteorology ingredients, it's not the values themselves, but it's those values occurring in the month of February that resulted in the unprecedented flooding that we ended up with. And if you remember back to earlier in February, we just had this massive ridge anchored over the Atlantic just off the southeast coast of the United States. And very anomalous for that time of year. And so what does that give you? That gives you that strong southwest flow up into the Midwest. And it really showed up well in the water vapor imagery. You can see the tropical connection as it streams, all that moisture streams on up into our area. And so we not only had the tropical connection, but you could also argue the Pineapple Express was in full gear too, coming all the way from the Hawaiian Islands. And so what did that end up with? Well, then you ended up with 400% of normal precipitable water streaming into our area for that time of year. And so, again, it's those ingredients coming together during that time of year when the ground, while there wasn't a great frost depth to it, it certainly wasn't completely frozen. So you're going to have a lot of runoff with whatever rain you do end up getting. And so that star shows you where the precipitable water was for our area, or near for Wilmington Sounding, for that 2-day period. And so it was near record PWs for that time of year. All right, since some of you are students, a little pop quiz. Look at these flooding pictures and tell me what doesn't look right. About 2 big-ass piles of snow. So one other ingredient that led this to being a record flood was over a foot of snow fell just 10 days before we got 6 inches of rain. And so it was estimated 1.5 to 1.75 inches of liquid equivalent was contained within that snowpack at the time that the rain occurred. And so we ended up with a record just over 8 inches of precipitation for the month of February at South Bend. Previous record was 5.23, so it smashed that record. 6 inches above normal for the month of February. All-time single-day record of 3.73 inches on the 20th. Previous single-day record was only 1.95 inches, so smashed that record as well. Single-day record for the entire winter season, and as Sam, our climate focal point, looked through more data, it was a single-day record for any month between December and May for South Bend. So again, it's really the meteorology of that coming in the month of February that really sort of led to that happening. So, and that was all I had for that. So thank you for your time.